Today, we're going to learn how to write code using the standard template library vector class. Hello, I'm James Helfrich. The vector can be a difficult data structure to use because the syntax can be a bit strange at times. I'm going to demonstrate how to create vector objects and how to look at their values in memory using the debugger.
Notice there are 7 different constructors for the vector. We'll look at each one of them in turn. Okay, we're going to start by creating a vector, just a default vector. Now we have to use the standard template library prefix std : vector, and that's the full name of the vector. You can get around that by saying using namespace std, and this will be a vector of integers. Now when I run it, notice that the capacity is 0 and the size is 0. This is the default constructor. Next, we're going to say the non-default constructor by passing in the size, which is 4. Now we're going to have the default value for each of the 4 elements. The size is 0, the capacity is 0, and the default constructor for integer is 0, so we're all filled with 0. Now another non-default constructor is to set the fill value. In this case, I'm going to have 4 elements, and each one is going to be the value 42. All right, now I'm going to do my personal favorite, which is initializer list. So I use the curly bracey, and this is a new initializer. Initializer is new to C++. I think C++ 14 it got introduced, but maybe C++ 11. Now I'm going to fill it with the values 2, 3, 5, 7, 11, and 13. Notice the size and capacity are both set to 6. Okay, now I'm going to have a source, which is going to be my first 6 prime numbers, and now I'm going to have a destination. Now what I'm going to do here is I'm going to do the copy constructor, which will copy the values of the source into the destination. And when I run it, sure enough, both the source and the destination have 6 elements and they have the same values. Now there's also the move constructor, and this is going to steal the values from the source and put it into the destination. And the end result is going to be the destination will have the source's values and the source will be empty. And sure enough, when I look at it, source is 0, capacity 0, size, and destination has 6 elements. And those are the most common constructors used for the vector. Next we have the assignment operators. I will cover how to create the assignment operator and the swap method. Okay, so we're going to start with a source, which is going to be 2, 3, 5, 7, 11, 13, and a destination which is empty. Initially, I'm just going to assign the source to the destination, and this should make a copy of the source's values. So I should have 2 vectors that have 6 elements in a piece, and I do. Okay, now I'm going to do the same thing, except I'm going to use std_move. And what this is going to do is it's going to steal source's data and put in the destination. So source should be empty, both size and capacity, and destination will have the 6 elements. Now this will also work if I give the destination some values, in this case 100 and 200. Now when I move it, then I'm going to get rid of the 100 and 200 from the destination, and source will be empty, just like before. The final thing we're going to do here is we're going to do the swap. So when I swap, then I'm going to trade source's values for destination's values. And when I run it, then source went from 6 elements to now 2 elements, and destination went from 2 elements to 6. So they swap values. Okay, so the vector also has iterators, and these iterators are a little richer than most iterators, and we'll demonstrate some of those capabilities. Okay, so the full name for an iterator is rather long. std, standard template, : vector int, and then iterator is a nested class, so it's : iterator. And now I'm going to assign it to the beginning, and it will point to the value 2, and sure enough it points to the value 2 through the pointer, and there it is. Okay, now let's create another iterator. Well, I'm going to shorten this. Rather than say the whole name, I'll say auto, and since begin returns an iterator, then it will take care of that complicated declaration for me, and this will work exactly the same. This is the preferred way to do it. Now I can also say it back equals vsource dot reverse begin, which is going to point to the last element in the vector. And we'll notice, first of all, that the data type of this is not going to be an iterator, but a reverse iterator. And notice how it points to value 13. So reverse iterator uses ++ in the opposite way. Now, one really cool thing about the vector iterator is I can compare the distance between 2 elements. So I'm going to compare the distance between the back and the front. And when I try to run this, I'm going to get something unexpected. I'm going to say, oh, compile error. And it's upset because I'm trying to subtract a reverse iterator from a forward iterator. So I'm going to have to do this a different way. So I'm going to say it2 is going to point to value 2, and it5 will point to value 5. And this is going to be vSource begin, and I can plus the iterator. I better make sure to iterator 5 here. I'm going to make a mistake. So it5 minus it2, and oh, I forgot to change the it++. Oh, that's right, I got to go to it5. There we go. it5. Now it5 is going to point to 5, and it2 will point to 2, and distance will show me the distance between them, which is 2 values. So I can always find the distance between two iterators with the minus operator. I can also skip ahead. I can say it5 plus equals 2, assuming that I type it correctly. There we go. Oh, I got to stop it first. Oh, it's going to get all mad because I didn't stop it. All right, just run it again. Okay, now when I run it again, the distance between 5 and 2 is 2, and it works just the way I expect. Isn't that cool? All right, the most common thing to do with an iterator is we want to visit every element in the collection. And so we're going to use our standard iterator for loop. For auto, it equals v.begin, it not equals v.end, and then plus it. Okay, and then what I'm going to do is I'm going to multiply it by 10. I'm just going to change it. So basically the dereference operator can both look at an element as well as change an element. And now when I run it, I don't expect it to have the primes 2, 3, 5, 7, 11, 13, but rather I'm going to expect to have 20, 30, 50, 70, 11, 110, and 130. The most common way to access elements in a vector is use a square bracket operator, or add if I want to do error checking. But front and back are also commonly used. Okay, so I'm going to have my vector of 6 elements again, and I'm going to say the head is v dot front, and then I'm going to say the tail, or the last element, is going to be v dot back. And so when I run this, I expect head to have the value 2 and tail to have the value 13. And we run it. And sure enough, head is the value 2 and tail has the value 13. That's just what I expect. Okay, so now I'm going to run it again. And this time I'm going to actually modify the what's in the front by saying front is 100 and back is going to be 999. So in other words, front and back are both read-only as well as read-write. I can have both read and write access. And sure enough, my vector changed. So the next thing I'm going to do is I'm going to say what's the value of 7. And 7 is slot 0, 1, 2, 3. 7 is slot 3, so I can read an element by using the square bracket operator, passing an index. And sure enough, that's the value 7. And we can also modify an element in the vector. So the square bracket operator is read-write as well. So I'm going to change the 777. And when I run it, I expect the fourth element to be 777. And sure enough, there it is. The most common way to add elements to a vector is pushback, which pushes elements onto the back. We have the copy and move. We can also insert a given iterator, and we can resize and reserve as well. Okay, so I'm going to have my vector of 6 elements here, and I'm going to push back the value 17. And when I run it, we'll notice that my size went from 6 to 7. And look at my capacity, and 17 is there. My capacity also changed. It didn't increase by 1. The important thing is that the capacity doesn't always increase by 1 because we want to have it be more efficient when I push back a whole lot. Some implementations double the capacity with every iteration. Now what I'm going to do is I'm going to resize by 10, and now my size, there we go, run it again. And so now my size will be set to 10, and my capacity will be set to 10 as well, and all the intermediate elements will be set to 0. But it turns out resize takes another parameter, and that's what I'm going to fill it in with. And by default, I filled in with the default constructor of integer, which was 0. But now I'm going to put 99 in all those extra slots. And sure enough, I look there, 99, 99, 99. So resize increases the size. But what if I just want to change the capacity? And I can do that with reserve. Oh, actually, let's do a resize 3. When I say resize 3, I'm going to take the size down from 6 down to 3. And notice my capacity still remains 6. I'm not going to change the capacity. I'm just going to change the size. Now when I say reserve, I'm going to have more elements in the capacity than the number of elements I have. So I expect to still have a size of 6, but now my capacity will be 10. And sure enough, size equals 6 and capacity is 10. So that's what I expect. There are many ways to remove elements from a vector, but we're going to focus on the most common. Clear, which removes all elements, pop back, which removes the last element, and shrink to fit, which removes extra capacity. All right, so the first thing I'm going to do is I'm going to clear, and I used to have 6 elements and 6 capacity, but now I'm going to have 0 elements and a capacity of 6. In other words, I did not reallocate the size of the vector. The next thing I'm going to do is I'm going to pop back, and that's going to remove the last element, so my capacity will remain unchanged, but my size will move down to 5. And notice how the element 13 was removed off the back of the vector. Now, in order for me to show how shrink to fit works, I first need to have some extra capacity. So what I'm going to do now is I'm going to reserve 10, so now I have a size of 6 and a capacity of 10, just like I did in the previous example. And now I'm going to, when I say shrink to fit, what this will do is get rid of the extra capacity. In this case, I'm going to save my size and capacity goes down to 6. And sure enough, it does. Size and capacity are both set to 6. So the last thing we're going to do is look at the size, capacity, and empty methods, which are going to tell me the status of the vector. All right, so I have, see here, I have 6 elements, and I have a capacity of 10. So if I say S equals vector.size, that'll tell me 6. And C equals v.capacity, and that should be 10. And finally, am I empty? So E will be empty, is v.empty, and that should be false because my size is not 0. And sure enough, when I run this, then we're going to see size is 6, capacity is 10, and I'm empty is set to false. You can learn about this and more details about the vector in the C++ Data Structures textbook.